So we are starting off correcting lesson 310 from Thursday and Friday. Did I fit it all? There we go.
Mr. Blair?
Yes.
Problem 2, you wrote 40.
I did. Thank you. 9 times not 40, it's 45.
Mr. Blair, can you scroll? Can you put it?
Can I what?
I can't see the bottom of the paper for the answer on number 17. Miss Triplet?
Yes.
Never mind.
Okay. All right. Any questions on this side?
We're not done. Nope.
All right, I'm gonna move to the back side. If you aren't finished, you can always come back and watch the video, or I will have the answers posted in Otis for you to check there as well. We'll start there. I'll move it up in just a minute. Any questions?
No.
Move it up a little bit so you can see all of the last one. All right, are we good?
Yeah.
All right, let's go ahead and take a look at lesson 311 then, today's lesson. All right, today we are going to be asked to create some situations where you might use that type of division problem. And for me, a lot of times it's easier to think about food when I'm trying to come up with these problems. Either food or like lengths of a board or fabric or something like that. For some reason, those two types of situations are a lot easier when thinking about fractions and dividing things up amongst people or into smaller pieces. So let's go ahead and take a look at lesson 311 here. I'm on page 95 in my student activity book. And the first one wants us to consider the division problem 2 divided by 5. So you need to think of 2. 2 is what you have amounts of that you need to divide into 5 of something. So like I said, a lot of times I like to use food because for some reason it's just easier to think about food. So on this one, I might say something like, I have 2 pizzas to share with myself and 4 friends, right? Does that give me 5? Yes, it does. Myself and 4 friends.
Yes.
How much do we each get? Does that give me 2 divided by 5? 2 pizzas, sharing it with myself and 4 friends. You take a minute to think of a problem. It could be the same, or it could be something a little bit different. Your choice. Did anybody come up with a different situation they want to share?
I said 2 pies.
2 pies? I love it. Are we awake this Monday morning?
No.
No, not so much. All right, so then I need to draw a diagram to represent the division. So I'm going to draw my 2 pizzas. And how many pieces am I going to divide each one of these pizzas into?
3
Good.
pieces.
Oh, really? 5,
5.
right? Because I'm dividing 2 pizzas between myself and 4 friends. That's 5. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
I was accidentally looking at number 2.
Okay. So if I'm gonna share these 2 pizzas with myself and 2 friends, I have 2 divided by 5. And remembering what we did last week, we said the first number stays the same. We change our division to multiplication and we flip. 5 becomes 1 over 5. And then when I solve that, I end up with 2/5. I get 2/5 of the pizza. Does that make sense?
Yes.
Yes.
Let's look at the next one. 4 divided by 1/3. So 4 is the amount that I have, and I need to divide that amount into thirds. Let's see. I have 4 yards of fabric. I want to make, let's go with the times here, masks. And each mask needs 1/3 yard. Okay, so I've got the 4 yards, that's my total amount, and I'm gonna make masks, and each mask that I make needs 1/3 yard of fabric. How many masks can I make? If I'm drawing my diagram for this one, I'm going to use probably bars here. So I'm going to do 4 bars. Each one is 1 yard long. 1, 2, 3, 4. There's my 4 yards. And each yard is cut into thirds, right? So how many masks can I make?
Twelve.
12, yeah. Let's check our math. 4 divided by 1/3. Same, change, flip. 4 times 3 is 12 over 1, which is the same as 12. I can make 12 masks. So when you have a fraction as your second number, it gets a little bit trickier. But like I said, a lot of times if you're talking about like measurement, that's the time when you can really use that fraction part there. You could say like I have to walk 4 miles with my friends, or we're going to divide it up into 1/3 mile sections. How many friends do I need so everybody walks the same? Something like that. And now consider the division problem 1/4 divided by 2. I'm going back to my food, okay? I like when I've got a whole number here in that second spot, I can use the number of people. So maybe I have 1/4 of a cake to share with myself, and we'll say my sister. How much do we each get? Okay, so to diagram that, I know I don't have the whole, but I want to think about it as my whole here. And I have 1/4. This right here is what I have. And if I'm going to share that with 2 people, I'm going to have to cut that into half itself. And let's think about all of those cut in half, because that'll help me with how many pieces total would have been in the cake to let me know what fraction that's going to be. So I have my 1/4 divided by 2. Same, stays the same. Change, division changes to multiplication. And flip, 2 becomes 1/2. Same, change, flip. I end up with 1/8. Does this show that I get 1/8 of the cake?
Yes.
Yes, it does. Okay, so the hardest part is thinking of the situations, but the more word problems you do, the more practice you'll get in seeing word problems. So look at this. Let's take a look at some more practice word problems. The tricky part on these is knowing which number is going to come first. Because remember, like we talked about last week, we used to be told, oh, the bigger number's always first. The bigger number's always first. Not anymore. You guys are getting bigger and smarter, so they're mixing it up some. So 1 lap around the track is 1/4 mile. Jose wants to run 5 miles. How many times must he run around the track? What's our total amount in this? What's our whole thing that we're going to divide up into pieces?
1/4.
Is the 1/4 the whole? And we're going to divide the 1/4 into 5 pieces? Or is 5 the whole that we're going to divide up into 1/4 pieces?
5.
The 5 is the whole, yeah, because we want to run a total of 5 miles. And so we want to know how many 1/4 there are in 5 miles. Equals R per run, we'll say. Okay, same change flip, same change flip. 5 stays the same. Change our division to multiplication. Flip our 1/4. When we flip 1/4, it just becomes 4. 5 times 4 is 20. So 20 laps is how many times he's going to have to run around the track. Okay. Number 5, there's 1/6 of an extra large pizza left over in the fridge. If 3 friends share the pizza equally, what fraction of a whole pizza will each friend get? What's our first number?
3.
Is the 3 friends what we're dividing up? Or is the 1/6 of the pizza what we're dividing up?
1/6 of the pizza.
The 1/6, yeah. We're thinking, what is that item that's being shared, that's being split up? The 1/6 of the pizza is what we're splitting. And how many people are sharing it?
3.
Yeah, divided by 3, and that's going to equal our pizza. Okay, to solve it, same, change, flip. When we flip 3, it becomes 1/3. Okay. 1 times 1 is 1. 6 times 3 is 18. We each get 1/18 of the pizza. Are we doing okay? You guys are so quiet this morning.
Yes.
All right. Oscar's aunt lives 50 miles away. This is 6 times as far as Oscar's grandfather lives. How far away does Oscar's grandfather live? This one's a little trickier because of that 6 times as far, but who lives farther away, the aunt or the grandfather?
The grandfather.
Father.
So let's read it closely, okay? Let's read it closely. The aunt lives 50 miles away. This is 6 times as far as the grandfather lives. So the aunt actually lives farther away than the grandfather. Because if you take the grandfather times 6, you're going to find out the aunt. Okay, so to solve this, I'm going to take what the aunt lives and divide it by 6. That's going to tell me how far away the grandfather lives. Equals G for grandfather. Same, change, flip. 50 times 1/6 gives me 50 over 6. 6 goes into 50. Let's see. 6 times 8 is 48. And I've got 2 left over. 8 and 2, 6 miles is how far away the grandfather lives. Because if we take 8 and 2, 6, multiply it by 6, that'll get us to 50. Grandfather times 6 gets us to the aunt. Oh, a banner has a length of 10 feet and the area equals 7. What is the width? What is the width? How would we set up this problem? How do we find area?
You multiply.
Multiply.
Why?
What do I multiply?
10 and 7.
Well, you multiply the sides.
Okay, I multiply my length times my width to find area, right? Do I know what my width is?
No.
No. So if I can't multiply these two, then I have to use the opposite operation. What's the opposite of multiplication?
Division.
Divide.
So 7 divided by 10 is going to give me my width, because 7 would be my total of that multiplication problem. Okay, 7 divided by 10 is going to give me my width. My 7 stays the same. I change my division to multiplication, and I flip. 10 becomes what?
1/10.
1/10, yep. And then 7 times 1 is 7, 10 times 1 is 10. 7/10 would be my width, 7/10 feet. Because 10 times 7/10 equals 7. Number 8, Brady has 3 goldfish. This is 1/5 times as many as Sam has. How many goldfish does Sam have? This one's kind of tricky. This one's like that one on number 6, right? Who's going to have more goldfish, Brady or Sam?
Brady.
If Brady only has 1/5 as many as Sam, he has a fraction of the amount that Sam has. So Sam's actually going to have more on this one. But we're going to start with Brady and his 3 goldfish. And we're going to divide it by 1/5. And that's going to equal G for goldfish. Okay. And then we're going to say our same, change, flip. 1/5 becomes what?
5.
Yep. 3 times 5 is?
15.
15 goldfish. Sam has 15 goldfish because Brady only has 1/5 as many as Sam. All right, we're almost there, friends, almost there. 3 more. Lucy has a half hour to decorate a dozen cupcakes for a bake sale. How much time can she spend on each cupcake? What's the whole amount that we have?
The cupcake. 1/2. 12.
So I'm hearing both. So you guys talk to me. Why do you think, those of you that are saying 12, why do you think it's 12? Those of you that are saying 1/2, why do you think it's 1/2? Uh-oh, nobody wants to talk about it. All right, well, when I'm looking at this, my amount of time is what I have to figure out, I have to divide up. So I have my half hour that I have to divide by my 12 cupcakes to see how much time I can spend on each cupcake. So 1/2 divided by 12 equals, we'll put a C for cupcake. Okay, so then I'm gonna go with my same, change, flip, and I end up with 1/24 hour. Okay, so a 1/24 of an hour is how much time I have that I can spend on there. And I could figure out how many minutes that is, but that's okay. We'll leave it like it is. Number 10, if 1/8 pound of uncooked rice makes 1 serving, how many servings are in a 15-pound bag of rice? What's my first number? Say it nice and loud. What's the whole amount that I have that I'm going to divide into smaller pieces?
15.
A 15-pound bag of rice, yeah. And I'm going to divide it into 1/8 sections to figure out how many servings of rice I have. So same, my 15 stays the same. I change my division to multiplication, and then I flip. 1/8 becomes what?
8.
8. Let me come over here. 15 times 8. So that's 0, 4, 8, 9, 120. I have 120 servings of rice. Last one. On Wednesday, 72 people watched the softball game. It rained on Friday, so only 18
Miss
people watched the
Triplet,
game. Yes?
Can I go to the bathroom?
Yes. The number of people who watched the game on Friday is how many times the number of people who watched the game on Wednesday. So we're going to take our larger group on this one, and we're going to do 72 divided by 18. 72 divided by 18 equals P for people. Because we're trying to figure out how many times larger 72 is than 18. So we can do our same change flip, which gives us 72 over 18. And how many times can 18 go into 72? Let's see. 18 goes into 72. I'm going to try 4 times. 4 times 8 is 32. Yep. So 4 times as many. Whew. That's a lot of word problems. That's kind of tough. How are we feeling? We're not talking.
Good.
Woo! All right, let's take a look at our homework, okay? I'm gonna have you do number 1 because you're writing up your own problem for number 1 and solving it. But then down here at the bottom, so you're gonna do number 1 and then I want you to do 2, 4, and 6. And yes, you need to write an equation. So number 1 up top, and then 2, 4, 6. And on the back side, we'll just do the odds. Okay, on the back side, we'll just do the odds.